Okay, we're looking at mixed exercise 5 from the first year textbook. And so we're on straight line graphs. We're on question 3, so it's an exam question, so we can see how many marks each part's worth. So that gives us an idea of how much work it should take. Okay, so I need to find 2 equations for part A. I need an equation for line 1. So let's do that one first. Okay, so what do they tell me about line 1? So they tell me that its gradient is 1/7. And it passes through 2, 2. So to be honest, I think that's all I need, because I'm going to use y minus y1 is m times x minus x1. So y minus my y coordinate is m times x minus my x coordinate. Okay, I can't leave it like that. It doesn't say what form to give it in, but I need to collect my like terms. So I'm going to multiply up by the 7, just because it then means I don't have to worry about fractions. So if I multiply up by the 7 from the denominator, then that just leaves me with a coefficient of 1 outside those brackets. And then let's bring everything over to the left-hand side. So, oh goodness sake, got the last question as well, right? Okay, but any correct equivalent is fine. So, for example, you might have ended up with y equals 1/7 x plus 12 over 7. That'd be absolutely fine. Okay, right, so that's line 1, and I'm pretty sure line 2 is just more of the same. So for line 2, they tell me the gradient is -1. Yeah, so just a bit repetitive. So gradient is -1. It goes through the point 4, 8. So y minus my y coordinate is my gradient times x minus my x coordinate. So if I multiply those brackets through by that negative, so depending on how I simplify it, I can either have y plus x minus 12 is 0, or y equals minus x plus 12. Either of those would be fine. Okay, and then determine the coordinates for C. So these 2 lines cross at C. Okay, so that's not too bad, hopefully. So there's line 1, or there's line 1 as well, either of those versions, and there's line 2. So just move up so you can see it. And then, yeah, so it's just deciding what I think the best way to solve them simultaneously is. So I would say my 2 main options would be use this version and this version, just put them equal to each other. I think my preferred method, just in terms of trying to keep it as straightforward as I can, would probably be to use those, because, so if I write the equation for line 1 out again. So the reason I'm going to this version is it doesn't have any fractions in. Okay, so pure, that's my only reason why. So there's line 1, and then if I substitute that in, so where this says y, I will substitute in minus x plus 12. So 7 times minus x plus 12, and then minus that x minus, is that right? Yeah, they are both 12. I think maybe I'm putting something down wrong. Equals 0. So minus 7x plus, I hope that's 84. That could be quite awkward. Okay, so I am going to add the x's over to the right-hand side. So I've got minus 7x minus x, so that will become 8x if I add it over to the left-hand side. And that equals 72. So there was no indication that x was going to be an integer, but it's always a bit of a, makes you feel like it's probably correct when that happens. So that gives me x is 9, and then it's just, I've got many options for what to use. I think I'll use that to find y, because I think that's in the easiest form. So y is minus x plus 12, so y is 3. And then it does, I think it's the coordinates, didn't it? Yeah, so just be careful. So if it asks for coordinates, obviously I've done all the calculations, but it's worth just giving it, well, you should just give it as coordinates. Okay, so let's just double check those answers. 9-3 we got. Yeah, so they've given both of theirs in the form y equals mx plus c. Yep, that is what we got, but any correct equivalent of those would be absolutely fine.